Hello everyone. Welcome to another session of IEEE CS 23 TechNiche series, session 4, the magic behind blockchain. Myself, Vishal Pokuri, a CSE blockchain technology student at VIT Vellore. Interesting things about me was I worked at 12 NFT Discord servers from January 2021, and I recently joined as a contributor at Super Team DAO. That's a lot of intro. All right. So I would like to express my heartfelt appreciation to IEEE for granting me this incredible opportunity. Thank you so much, IEEE for this wonderful opportunity to participate in such a remarkable event. So you might be wondering why the theme is named The Magic Behind Blockchain. It's just a piece of software with a little improvement, right? Well, that's where the beauty lies, in its simplicity. Here are my favorite lines from Kas Danda, the founder of Super Team DAO, about Web3. In crypto, prices go up, they go down. Regulations come and go. Projects start and have to end. Crypto is a crazy place, but there is one thing that always stand up all out of this crowd and craziness, and that is builders and community. And yes, Web3 is special because of these communities behind it. Um, so here is our agenda for our session, starting with the introduction. What is blockchain? Why blockchain? How does it work? And let's see what next. Wait, before entering into our session, I have a story to tell, and the story begins with this manner. Mhm. Once upon a time, there was a clever person who came up with a very special way to exchange money without using banks and governments. This person had a great idea called blockchain. It's like a digital notebook that everyone can see, but no one can change without everything, like everyone else knowing. So in 2009, the first block of this blockchain was made, and it became the start of a new kind of money called Bitcoin. People liked using Bitcoin because it made buying things online easier. So, but blockchain wasn't just about money. It turned out that this idea could help in other ways. It could make sure things like supply chains, medical records, and voting systems were safe and fair. So, and the person behind it is a guy, a girl, or no one knows. He called. His name is Satoshi Nakamoto. The person who came up with this blockchain is a mystery. No one knows their real name and their gender too. Sorry for that. But their name is Satoshi Nakamoto. Since then, lots and lots of people have been working to make blockchain even better. They've created different kinds of blockchains for different purposes. So, what exactly is blockchain? Consider it a linked list with a whole bunch of data and a reference to the previous block, like we call the address of the node here. The interesting thing lies in the date of a block. So, what exactly does a block carry or the data carry? Let's see it in the next slide. So, let's open this link. Let's see some magic here. So, this is a block, and this is the block number, and this is already completed, and this is a timestamp. The block has been created and completed, and this is this is my address, and this is the receiver's address, and I sent 0.061 Ethereum, which valued $123 at the time, at this time, which is January 25th, 2023. And you can get lots and lots of information here, like the Ethereum price, the currency price that I sent to the receiver is $1,610 at this particular time. And yeah, these are the gas fees, like the transaction fees uh, like I need to pay to the blockchain in order to uh, send my money to the receiver. This is mandatory for blockchain. Yeah, that's a lot about it. This is what consists in the block. So let's get back to here. So when it comes to the technical definition, at its core, blockchain is a decentralized and transparent digital ledger that enables secure and immutable record keeping, unlike traditional systems where trust is placed in intermediaries like banks and governments. Blockchain allows participants to trust in the technology itself, creating a P2P network of trust, which means every individual can have access to every record that is made on the blockchain. To understand why blockchain is important, Let's look at how the internet has changed over time. In the beginning, we had Web 1.2, where we could read things online, a read-only interface. Then came Web 2.0, where we can sign in and we can give inputs and take outputs, and the signing process with the already existing accounts and apps like Google, like, and the Apple ID, the Facebook, and the Twitter. And but something was missing, and that is trust pressure. That's where the blockchain comes in. It's like the hero of Web3, where trust becomes the most important thing, making sure everything is secure and fair. No more cookies to collect your personal data, no more trackers to monitor your every move. Let me show you what exactly I meant. Here. This is actually a Web3 kind of interface. OpenSea.io. This is actually an NFT marketplace, and we will dive deeper in the further slides. So, okay, it's already logged in. All right. This is the interface when you open the OpenSea website, and there is no such prompt like login with Google or Apple ID or Facebook, anything. It requires wallets. I will tell you what is the wallet and everything. So there is a provider called MetaMask, and I do have the MetaMask wallet, so I'm clicking on the MetaMask. So it is already connected. I will try with another wallet. So this is my another wallet called Phantom. So we will get a login request in this manner here. So let's connect, and boom, it is connected. And yeah, that's as simple as that. Just um, connecting your wallet. That's it. It's just a one click away. So let's get back to here. So blockchain is based on three principal pillars. That is decentralization, transparency, and immutability. What exactly does they mean? Yeah, let's go. So first, decentralization means the power of that the power and control are distributed across a network of computers. Those are called nodes, rather than being concentrated in a single authority. Like let's say it's having many friends who all have a chance in decision making, rather than having one boss who makes all the rules. This decentralized approach prevents any single entity from having too much power. And coming to the second one, the transparency. Transparency is a key feature in blockchain where everyone in the network can see all the transactions and information stored in it. It's like having a transparent glass jar where everyone can see what's inside, right? It's like having a group of friends who can all see and verify what's happening, so nobody can cheat or hide things. Sneaky guys. And the third one is immutability. Like immutability is actually a fundamental feature, which means once something is added to the blockchain, it cannot be changed later on. It's like writing with a permanent marker on a whiteboard. You can't erase it or alter once it's there. And let's see how blockchain works. And here is the actual magic. The working principle. These things happen when a person wants to send some money or crypto to another party. So the transaction is requested, the block that represents the transaction is created, blah, 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 and finally the transaction is complete. So I'll show you. Let's go in detail. Let's say I want to send some money. Uh, I will send my money from my wallet to another wallet. I will show you the process. Let's open my Phantom wallet. This is the receiver's wallet, and I need to send money to this one. So here we can see that we have some like hexadecimal codes over here. So I have Solana. I mean, the currency name is Solana. I need to send Solana to this wallet, particular wallet. So I'm taking the address of it. So it's like our phone number, our UPI is connected to the our phone number is connected to our bank account and we create a UPI, right? In that manner, instead of creating a UPI address or UPI ID, we already have a Solana's dedicated address here. So let's copy the address, and I'm opening my another wallet called Glue. Yeah, and it's open. So I need to send money. How can I send? So I will click on the send option. I will click on Solana, and I will paste the recipient address here. And let's say, hey Vishal, eat pizza, enjoy. Confirm recipient, and I will send all of the money from this wallet to that wallet. So I'll get a preview, and I need to pay a little transaction fee as I mentioned here. uh, this one, the transaction fee. But in Ethereum blockchain, it's like 40 rupees. But here it's in millicents. So here it's less than a cent, right? So I'm confirming and sending. The transaction is submitted to the blockchain, and from here to the recipient, I will show you the process how actually it works. And yeah, let's check if I got the money or not. And yeah, my money is here, and I can see here our transaction is succeeded from this particular address. That is the previous one that I got. Yeah, this is how a transaction works. So the first uh, the first sorry, the first stage is to initialize a transaction. So here in Phantom, this is the interface that you saw previously, and this is how MetaMask interface looks like, and this is how we initiate a transaction. And after that, for that you need to validate in the similar manner. You can store your money in the form of cryptocurrency, and there are some good wallet providers like MetaMask, Phantom, Glow, and Backpack, etc. You can go and check it out. It's free actually. And moving on to the next slide. And after the successful transaction initiation, we will be having a pending block in the blockchain seeking for verifiers. Like, see here, we can see here the status is unfinalized, which means this block is seeking for verifiers to verify this particular transaction here. And after the verification, it will be sent into the blockchain and the process will continue. I will show you in the next slides. So here the transaction is unfinalized. So the third step will be the transaction broadcasting, which means I created a block and I'm seeking for verifiers to verify my transaction. We will be having a pending block in the blockchain. So the transaction is sent to many people in the network who will check if it is real or not. They all need to agree that the transaction is okay. These people are called as miners. I will come to the miners after, and this is what happened. So the miners will validate the transaction by solving complex puzzles, ensuring that it's safe. From our end, like we are getting our block valid, like verified, right? So we call it validating transaction, but from the validator side, it's called mining. So what are those math problems and how do they solve them? In simple terms, these puzzle involves finding a specific number called a norm. When combined with the date of a transaction or the block being validated, produces a specific pattern or hash value. I will get to the hash value in the upcoming slides. So let's consider it a key, a key to the block, right? Miners will repeatedly guess different nonsense until they find the correct one that satisfies the required pattern. It's like trying to guess a secret code by trying out different combinations until you find the right one. And the first one to guess it wins and gets the reward. And the last step, the block will be added to the existing blockchain. The data is written will become immutable. The transaction is complete. And this is how the journey of a transaction goes beyond our computers, behind our computers, safe and secure. What next? I'm screaming. I will explain it further, and these are the further things. Let's talk about consensus in blockchain. In blockchain, a consensus mechanism is a set of rules and protocols that allow participants in a network to agree on the validity and order of transaction. It's like having a common agreement among a group of friends about the rules they follow when playing a game. It's like a group of friends playing a game without a leader. They all have a say and work together to make decisions. So we have different types of different consensus mechanisms for different blockchains. Some of them are listed here like proof of work, proof of stake, delegated proof of stake, Byzantine tolerance, proof of authority, POET, POH, and etc. and etc. There are a lot, but these are considered to be important. Before understanding how proof of work works, let's watch a video to make it crystal clear. And
Welcome to the Blocktown. Blocktown, a thriving city, is running out of supplies. The mayor orders a shipment from another country, but there's a suspicion it might contain bombs. The delivery van screeches to a halt outside the warehouse, its doors swinging open to reveal a cargo of mysterious crates. To safeguard the lives of our beloved citizens, the mayor has assembled a team of highly skilled bomb squad members. Their mission, to examine each crate, ensuring the danger is neutralized. Let the time taken by the bomb squad member for the successful verification is T. Then, member A's T equals 2 seconds. Member B's T equals 4 seconds. Member C's T equals 6 seconds. And member D's T equals 8 seconds. The mayor has provided clear instructions to the bomb squad members for checking the suspected bomb-filled crates. Each crate should be checked twice for enhanced verification, but no one should check the same crate twice. The inspection process starts with crate 1, and once 2 successful verifications are done, the team can move on to the next crate. To ensure safety, each crate is placed in a separate room, totaling 10 rooms with 10 crates to be checked. Mayor also proposed that for each successful verification, they will get a reward of 1,000 rupees. And everyone agreed to the mayor and started working. They worked in the following manner. 3, 2, 1.
and this is how proof of work. Not exactly, but to make it simple, this is the animation. Like this guy has more computation power. I will come to that. And this guy can solve. I mean, this guy can check if the bomb is present or not, and can verify if it is safe or not in just 2 seconds. And that is how he can jump from here to here to here in 2 seconds. And this particular guy can check the bomb in 4 seconds, and that's why there is nothing to be verified, right? So 2 out of 2 verifications have been done. So this guy shifted to here, and with this guy these both are also shifted together, but they are not able to get some money or reward because they are unable to complete the verification as fast as him. That's why only A and B are able to get the money or reward for the verification. And yeah, this is how proof of work works in a representation in a nutshell. So let's get back to the presentation. So this proof of work works, as I said before, in the mining section. In proof of work, miners compete to solve complex mathematical puzzles or algorithms. The first miner to solve the puzzle and find the correct solution, known as the node, gets the right to add a new block to the blockchain and receives a reward in the form of cryptocurrency or some other kind of money or so. So let's say you ask me to choose a number from 1 to 10,000. I chose 7,653, and you start guessing the number, like you start guessing it 1, 2, 3, 4, 5, till you get 7,653, uh, till it matches my choice. So the number, the key is what I'm saying. It's a form of data called SHA-256, which is also called as Secure Hash Algorithm 256-bit. So it is a cryptographic hash function. It takes an input such as a block of data or a message that we created a block, right? So it will take that block, that particular block as an input and produces a fixed size output of 256 bits, which means the size of that particular key is 32 bytes, like 256 by 8, which is equals to 32 bytes. So, in the context of blockchain, SHA-256 is used extensively in mining. Miners compete to find a nonce, a random number that, when combined with the other block data, produces a hash value that meets certain criteria, like the difficulty target or the number that I said, 7,653. This process involves repeatedly calculating the hash value until a valid hash is found, which is a computationally intensive task. Like the difficulty target, what I mentioned, we can say it, I need a number greater than 8,200 and something something. So in order to get that, the miner need to guess it repeatedly. And this, which is a computationally intensive task, and it takes lots and lots of energy. So getting back to the video, why do you think this bomb squad member A, just a second, why do you think this bomb squad member A's time is 2 seconds? Exactly, it depends on the computation power. The unit of the computation power is hashes per second, and that's why from the definition, the first miner to solve the puzzle and find the correct solution will get the reward. And the drawback is it will take a lot of energy, and you can see the drawback here. You can actually observe it. The energy consumed by everyone is similar, but only A and B can get the reward. So the C and D will not get reward because they cannot compete with A and B, which is unfair. So, and that's why we have the show stealer proof of stake. So, unlike proof of work, which relies on computational puzzle, uh, POS, aka proof of stake, operates on the concept of staking. What is staking? So let's say I have 1,000 rupees. Staking is like putting your money into a savings account, which we call it here the staking vault. That helps keep the currency secure and the network running smoothly. So what if I change the story? So let's take person A. Instead of having lots and lots of machinery and computational power to solve complex problems, let's say he had lots and lots of experience to defuse a bomb. Like he can defuse a bomb in a snap of second. Let's say here 2 seconds. So that experience here is called staking. It's like a beginner who is new to trading will invest 1,000 or 2,000, but experienced people who have very who are knowledgeable will invest 1 lakh or 2 lakh or 2 lakh or more. So the more coins you stake in the network or store them in that particular staking vault, in return for their dedication, they have a chance to get selected to create a new block and earn rewards, which is like verifying that block. So if I have 10,000 coins and person B have 5,000 coins, and I have more chance to get that block to get verified, I will verify that particular block and I will send it to the blockchain and I will get reward for that particular verification. So, and this will need lesser energy. And as per the statistic, POS has 99% energy reduction when compared to POW. That's actually a great thing. That's actually a great thing. So we conclude that in proof of stake, the probability of being selected as a validator is directly proportional to the amount of cryptocurrency a participant holds and has staked. And that is the reason Ethereum changed its consensus mechanism from proof of work to proof of stake and shifted its focus to the ecology and our livelihood. Kudos, Ethereum. So, without applications, the use cases, this session does not have a meaning. So, let's get started with NFTs. What is NFT? So, the abbreviation is non fungible token and they look like this. Ah, come on. What's so special about it? It's just a piece of JPEG image with a silly monkey smoking with a cringy cat, looking like he hasn't slept since a week, like me. So this is an NFT from a project called Board Ape Yacht Club. And guess what? This particular NFT costs around 112 Ethereum, which is equals to um 1 crore 80, 85, 87 lakhs. But you can ask me this question. Vishal, I will take this NFT, duplicate it, and sell it for the same price. What's the big deal? Sorry to say this, you cannot. Non-fungible mean you cannot make a copy with the same data, like exact same to same. I mean, you can copy it to make it simple. I have a house at 14-degree north and 18-degree east latitude, longitude and latitude, the coordinates. One guy wants to copy my house, the infrastructure, the interior, the paints, the decorations, everything exactly same to same. Let's say he made it finally. Can he place his house at the same 14-degree north and 18-degree east coordinates or the same location? You got the answer. Impossible. So that is the speciality of non-fungibility. In the same way, when we peek into our monkey in detail, in detail, um, yeah, this is our cringy monkey. We can see it in the marketplace called OpenSea. And when we dive deep here, when we come to the detail, this is the contract address. What do you mean by contract address? Le- Uh, Before that, I showed you a hexadecimal code, right? This is my address and this is the creator's address. So he made it and launched it into the blockchain. So this NFT is official and only official when he creates, when this guy creates this NFT. You can copy it like I will show you. I'll just copy this JPEG image and open and create. I need to sign in. So I will drop it. Okay, I will duplicate it first. I will drag this particular JPEG image and drop it here. So it is not taking actually. I'll save it. Okay, this is an AVIF file. All right, no worries. I can drag my photo or video or any MP3 these type of files, and I can give the item name similar to this hashtag 5819 copy in here in the external link of this one, and a description that is here by Board API Club. There is no description here actually, and the collection. We can give all the details exactly same, but this address is there, right? You cannot copy it. so I am the creator, right? My particular, what do we say? Just a second. This address. Only this address will be displayed when I create this particular NFT exactly the same. But you cannot see this address because when I create, I know that I copied, but I cannot give any value to that, right? So, in the same way, when we peek our monkey into detail, that cannot be copied or changed or tampered. I can copy the same NFT and create, but I cannot give the value similar to this particular NFT. This is actually a good example of fungibility and non-fungibility. Here we can consider a dollar and copy it similarly. Um, Even the serial codes on that, we can copy it and create a similar, not similar, exactly the same copy um, of that particular node, but no one can find it copied. I will take the same material. I will take the same link too. Sorry, I will take the same ink. I will take the same machinery to produce the node, and I'll give it to the shopkeeper. Jai Farsi. Also with the digital currency, but here there is a limit called supply. Here we can see Bitcoin's supply is 21 million coins. Only 21 million coins can be created on the blockchain. You cannot create tokens beyond that supply limit, right? And yeah, you cannot copy from me now. And the session ends with our last slide here. Feel free to contact me via Instagram and LinkedIn because I'm here live. I'm not a cat, okay? So, thank you for joining this session and see you all.